What's going on, you guys? My name is Charles, and this is the Traders Corner. Today we're going to be talking about the process to build a trading strategy from coding. So let's get started. So today we're going to be talking about building a trading strategy while using coding. Now, what do I mean by that? I mean, I'm going to talk about the overarching process that you would want to go through to actually build a trading algorithm or a trading strategy through coding. And we're just going to cover 5 simple steps here. And it's, again, it's a very overarching high-level discussion. I'm not going to go into too much depth on each step, but I'm going to give you a general idea of what you can expect or what you should probably be doing in these steps. Now, the first thing that we're going to want to do is we're going to want to actually define our trading strategy. Now, you might want to trade based off technical analysis. You might want to trade based off of, fundamental analysis. There's a lot of different things that you can do as it relates to trading using coding or building a trading algorithm. And that's why I find it so helpful and so useful to my trading, because there's the ideas that I can have and just quickly put them together and then see how they work. Like, for example, I had an idea of trading when the stochastic was basically crossing while it was oversold. And then, the RSI was also in a certain area within the RSI. See how that worked out. Did not work out well. So that's the first thing you want to do, is you want to define your trading strategy. Or maybe you want to build more like a machine learning algorithm that literally predicts the price that Bitcoin might be, right? And buys and sells based on that prediction. So that's the first thing that you want to do. You want to define your trading strategy. Next, and this can be made easier using the help of what's called packages, or maybe even different libraries, or maybe just different development environments, right? So the next thing that you want to do is you're going to collect and clean your data. Now, what do I mean by, different environments or packages or data can make this easier? So for example, I do a lot of my trading algorithm work through what's called QuantConnect. And QuantConnect is essentially, it just started out as what's called the Lean library. But essentially, because they had the Lean library and they had all these different functions and methods built to make trading easier or backtesting easier, they just decided to put it all into one basically, integrated environment where you could do everything that you need to do as it relates to building a trading algorithm. Now, you don't have to use QuantConnect, and you don't even have to use their development environment to use the Lean library. You can use it in just regular Python, development environments or anything else. You can use other libraries, like maybe TA-libs is another good library for example, technical analysis. But a lot of these other libraries, like TA-libs, for example, doesn't come with data with it. So you have to find a way to get that data and clean that data to make sure it's feeding through to your algorithm the way that you would expect. So that's going to be the next thing that you want to do. Now, after you have the data cleaned, if you need to do that, you're going to want to actually go about developing and coding that algorithm. It's a very, self-explanatory process about what you're actually going to be doing there. But again, like I said, you're just going to want to make sure that you're going through and coding the algorithm. And the thing that I'll call out in this part of the process is to make sure that after you have coded your algorithm and you test it, you really want to come back to step 3 and look for ways to make your algorithm more efficient. For example, I was building algorithms and, just to kind of get things done and get them out the way and try to get them tested and out the door, quote unquote, I would just leave everything in the onData function, right? And eventually, Daniel kind of looked at some of my algorithms and he was just like, look, like the algorithm's not wrong, your coding's not quote unquote wrong, it's just it's not very efficient because you have basically everything in the onData method or onData function, however you want to call it, right? But that being said, what I went and did was I eventually just went and built different methods or functions to do the different things that I needed to do in terms of trading, like creating my variables, checking if they're true or not, creating entry parameters, creating the actual order, all that kind of stuff. And then I passed these methods or functions into the onData function, so it's a bit more clean, right? So that's the first thing that you want to, that's the third thing that you want to do. You want to actually develop your algorithm. And then once you go through number 4, like I said, which was testing and validating your algorithm, and you know that it works and it's something you want to go forward with, you should go back and make that algorithm more efficient and basically do step 3 again. Now, again, like I said, why do you want to do step 4, which is testing and validating it first? Before you do that, you don't want to waste your time trying to make something efficient that you're probably not going to use anyway because it's not profitable. Now, testing and validating, I'm glad I brought up the idea of profitability because I want to talk about the idea of overfitting, right? This is definitely something that you want to look out for when it comes to back testing. For example, if you're using technical analysis, chances are you're probably going to get hit with some overfitting in terms of your back testing, right? What do I mean by overfitting? Overfitting just means that essentially your algorithm looks too much at the data that you passed it. What do I mean by it looks too much at the data that you passed it? Say, for example, I'm building an algorithm that trades on EMA crosses, and I collect and clean data on NASDAQ futures from 2021, right? From 1/1/2021 to 12/31/2021, okay? That's the data I collected, and that's the data I pass it. Essentially, overfitting would be telling me that, yes, it may have worked in 2021, but I cannot tell you for sure that it is going to work in 2022 because you're so in tune with the 2021 patterns, right? So that's kind of something that you want to look out for as it relates to testing and validating. How you can go about getting this done? Again, you can use things like QuantConnect, where you can do all of that right there, or you can also just build different backtesting algorithms yourself through different backtesting libraries that are also available in Python, right? Again, like I keep saying, even though I use QuantConnect, it is literally just built off the Lean library or the Lean package that you can go out and get in, for example, PyCharm or whatever development environment that you might be building in Python in. Now, the last thing that you're going to do is you're going to, after you test and validate it, you're going to want to deploy it and monitor it, right? So again, you can use integrated development environments like QuantConnect to make sure that you're deploying it right, all this good stuff, and you don't really have to go out and build your own API to deploy it. QuantConnect gets access to the APIs for you, and they just basically go in and they connect whatever account you tell QuantConnect to connect to, and then they'll make sure that you have the API and all this kind of stuff, and it's kind of their responsibility to keep it up. So it's like, for example, when you're deploying your algorithm on QuantConnect, you can click this button that tells it to automatically restart. So say, for example, the API goes down for whatever reason over at QuantConnect, their connection to the API goes down for whatever reason over at QuantConnect. Once they have that connection reestablished, they'll automatically restart my algorithm, right? But like I keep saying, you don't have to use QuantConnect. You can do it yourself, but you are gonna have to go about that process of building your own API to connect to whatever broker that you want to take it live on. A lot of brokers have access, have very easy access to their API keys and APIs, and so it's like it's pretty easy to find. So like, for example, if you literally just type in TD Ameritrade API, it's gonna be like the first or second thing that comes up on Google. So it's pretty easy to find. Awanda's the same way. Interactive Brokers, I have pretty much the same experience. So it's not that hard of a process, and you'll learn something from it from building your own API. But it's just, if you don't want to have to worry about that, worry about you fixing the API connection if it goes down or anything like that, then I would definitely recommend using something like QuantConnect. But just to recap very quickly, we talked about the 5 things that you're going to want to do as it relates to building your own trading strategy through coding. And we talked about them at a high level. So let's just quickly recap them one by one. First, we want to define our trading strategy. Then we want to collect and clean data. After that, we need to develop our algorithm or code it. Then we want to test it and validate it. We're likely going to want to come back to step 3 and find a way to make our algorithm more efficient if it passes our testing or back testing. And then once we make it more efficient, we want to go ahead and take that algorithm live using either whatever API key that development environment that you're using has access to, or building your own. So I hope you guys enjoyed this video. Hope it provides some value to you guys, and join us next time. Thank you.